plus or minus the square root of b squared minus 4ac all over 2a. Now you try. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
Hello and welcome back. We're on section 12.4, the last section of the year, so if you've made it this far, congratulations. Let's go ahead and start looking at what we have here. We have a lot of work cut out for us today, but I'm going to show you a way, and this is, this idea is the way to solve any quadratic equation. The only way that we have right now is we have graphing, but that can be kind of hit or miss. And then we have, if there's no bx term, that we can find the find the square root of the x term, of the x squared term. So those are the only two methods that we have right now, but we really need to know what to do when we're faced with a problem such as this one, where we have an x squared term, an x term, and a constant term. So this way will always work. It's called the quadratic formula. You probably heard that song, related to Pop Goes the Weasel before this. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, and so that's really all this box is saying. It's saying that formula itself, and it shows you how to read it, out in words also. So the key here is that you need 0 on one side, everything else on the other. We have that to start right now. So we know this is our A, this is our B, and that's our C. So let's see what happens when we plug this in. So negative B, so negative 5 plus or minus the square root of B squared minus 4AC. Keep in mind that this thing under the square root has to end up being a positive number. Or 0 if that works out, but it can't be a negative number. All right, so here we have times 2a, so that's ugly, but 2 and a is 3. So then what we need to do is, if we work this out step by step, I'm going to take one step to simplify what's under the square root, probably 2 steps actually, but I can fix that thing out in front first. So it's just a negative 5 plus or minus 5 squared is 25. 4 times 3 is 12 times 7 would be 84. And since that's a negative 7 and that's a negative 4, we're going to have plus 84. All over 2 times 3, which is 6. So as you can see, I'm doing multiple things at once. And that's really the only way to survive and not have a problem that takes up a page once it's all said and done. All right. So let's look at what we have here. I'm going to use a calculator to figure out that square root, and 25 plus 84 is what? It's 109. So I'm going to take the square root of 109, and let's get that to where you can see it a little bit better. So square root of 109 is going to give me 10.44030065. I'm just going to round that to the nearest hundredth. That's what I usually ask you to do with decimals. So we're going to call that 10.44. So what we're left with here is negative 5 plus or minus 10.44 divided by 6. Okay. Now if you notice, we do have that plus or minus on there, and that's a big thing because we're going to have 2 answers on all these. Just like we did when we solved by square roots, okay, we're going to have 2 answers on these ones as well. So let's start with the positive. So negative 5 plus 10.44 divided by 6 gives me 0.9066. Let's call that 0.91. And we're going to need the other one. So we want to go negative 5 minus 10.44 divided by 6. So we get negative 2.57333. Call it negative 2.57. Negative 2.57. So that's how to do the entire problem. Those are the 2 answers, the 2 numbers that make this equation up here true. All right. So, and looking at the graphing side of it, the graph would cross the x-axis at 0.91 and negative 2.57. So definitely some odd answers, some difficult answers. They'd be really hard to find just by graphing. So this is a way that's always going to work. There are other sides or other ways to solve quadratics, but none of them work out every single time. Okay, there's a lot that are easier than this, but maybe they only work if some conditions are met. This one works every single time. Okay, and it's going to tell you the answers that you're going to get. But what I want to start off doing is I want to start off looking at, this is kind of some practice. The problem has already been put into the into the quadratic formula, and we're actually to this step right here with this being negative 5 plus or minus the square root of 109 over 6. That was the intermediate step between these two steps. So what we're going to look at on this front page are just versions of this, and we're gonna write them in different ways. So if you look at the way that we did this one, we wrote the square root as a decimal. Now obviously that's rounded. Okay, it was an irrational number. It filled up the calculator screen. So what we're going to do is we're going to be looking at these, and whenever we're expressing as a decimal, again I want to round to the hundredth. And remember, that's just 2 decimal places. Okay, so let's look at a couple of these. So we have negative 11 plus or minus square root of 681 over 14. I'm just going to rewrite that as negative 11 plus or minus. I'm going to use a calculator to figure out what the square root of 681 is. Square root 681. And we get 26.095. That's going to round up to 26.1. So we're going to write that as 26.1. You could write 10, but it doesn't make much of a difference for us right now. And we're going to divide that by 14. So I'm going to show you a way on the calculator that makes that a little bit easier to do both the plus version and minus version. I'm going to put it in as one equation here, or one expression. So I'm going to go negative 11. Not negative 111, negative 11 plus, and notice I'm putting this in parentheses, if you can see that. There we go. So I'm putting this in parentheses because it's the numerator. I want it to figure out the numerator first, and then divide by 14. Okay. So when I plug that in, I get 1.0785, and a long string of numbers. It'd be very ugly, a very ugly number there. So we're just going to round that to 1.08. So that'll be 1.08. And now to do the other one, I just use my up arrow to go back up into that equation. And I go change that plus sign to a minus. And then hit enter, because the number stayed the same. And now I get negative 2.65. Okay. So, and negative 2.65. And those are my 2 answers. Okay. What I want you to do right now is go ahead and pause the video and try the next one. Okay, welcome back. Hopefully you had a chance to get that done. And we're going to follow this style throughout this whole page. Sorry, I was struggling with that. I'll do one, you'll do one. I'll do one, you'll do one. Just so we can get a good mix of, me doing the work and you trying it out also, because you're not going to learn it if you don't do it. Hopefully you started off finding the square root of 739 as 27.18. So we know that this is 9 plus or minus 27.18 all over 6. And then what we do from there is put it into our calculator. I'm going to use parentheses again. 9 plus 27.18 divided by 6. So I get 6.03. Whoa, 6.03. And change that to a minus sign. Negative 3.03. So those are my 2 answers. Hopefully that's what you got. Okay, and if not, look at what I did, look what you did, find the mistake, and fix it. Not a big deal about mistakes right now. Okay, the next group of them, we're going to be simplifying radicals. And so we're going to put our answer in simplest radical form. So we're not really going to use a calculator. Okay, let's look at what happens here. Let's split up 120. 120, well, I know that it's 10 and 12. And 10 splits up into 5 and 2. 12 splits up into 3 and 4. And 4 splits up into 2 and 2. Really ugly there, but the only exit buddy we have are a group of 2's here. All right. So what that actually is we pull out a 2, and then we have 3 times 5 times 2. 3 times 5 is 15 times 2 is 30. So that's going to be 2 root 30. Okay. And now what we have is we have 10 plus or minus, put an equal sign down here, 2 root 30 all over 2. Now what I'm going to ask you to do is, since there are common factors in both things up top and the one thing in the bottom, you want to reduce that. So another way to write this, if that doesn't really make sense, what we really have here is 10 over 2 plus or minus 2 root 30 over 2. Okay, it may help you to write this step out until you really get the hang of it. So 10 over 2 is 5 plus or minus. The 2's cancel out here. We don't touch the radical. Okay, we don't touch the radical when we're reducing this fraction. Okay, we're only dealing with the coefficient on the radical and the number on the bottom. Okay, but those 2's cancel out, so we just get square root of 30. And that's my answer. So the beauty with writing it in simplest radical form is you don't have to deal with the plus and the minus. Okay, you just figure out one of them and then move on. Go ahead and pause the video and try the next one. Remember, we're looking for simplest radical form. Okay, welcome back. Hopefully you had a chance to get that done. Let's see what we have here. 98 splits up into 49 and 2. And 49 splits up into 7 and 7, giving me an exit buddy of 7. So this is negative 6 plus or minus 7 root 2 all over 2. There's no way to make reducing that worth it. You may have wrote like negative 6 over 2 plus or minus 7 root 2 over 2, okay, which would then simplify to negative 3 plus or minus 7 root 2 over 2. Okay, that's another answer, but honestly, this one's quite a bit easier. Okay, so either one of those would be okay. The only time I require both of them to be simplified is when they can both be simplified just using integers and not using decimals. Yeah, this could say 7 divided by 2 is 3.5, but that doesn't help us out at all. All right, so only do it if they both can reduce. I know that's kind of difficult and we're making a bunch of rules, but it's actually not that bad. If you just notice that, you know, they're both even or they're both multiples of 3 or something like that, and that's the number that you have in the bottom, okay, then do something about it. But if you're in doubt, you can always ask me, and I can tell you whether or not you should reduce that or not. Okay? So let's look at the next ones. So it says practice getting cool answers. Let's see what we mean by cool answers. Well, what's the square root of 64? Well, let's go here. Square root of 64 is 8. Okay, so that's what's cool about it. I don't have any radical. I don't have any decimal. I'm going to get two actual answers here. 4 plus 8 is 12. And we have an and here. 4 minus 8 is negative 4. So what do we get for our answers? We get 12 over 4 is 3. And that looks like a negative 1. So that's what's cool about that, is the square root turned out to be a perfect square. And we just get a single answer. Okay? Go ahead and pause the video and try the next one. All right, welcome back. Hopefully you had a chance to get that one done. What's the square root of 625? Well, that's a tough one, but it is a cool answer. It's 25. Okay, so what you actually end up with, you go negative 25 plus 25, you get 0 over 5, which is 0. And negative 25 minus 25 is negative 50. Divided by 5 is negative 10. So those should be your two answers there. All right. So now we're actually going to look at using the quadratic formula and having to put those numbers into the quadratic formula. And we're going to start off with the special cases. All right. And I've left them in the quadratic equation form to prove a point here. So let's look at x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? Negative b, so that's a negative 7 plus or minus the square root of negative 7 squared minus 4 times 2 times 8. All over 2a, 2 times 2. Okay. I guarantee you, if you're going to remember anything out of that song, it's going to be the all over 2a. So negative 7, that's positive 7 plus or minus. 7 squared is 49 minus 4 times 2 times 8 is 64. All over 4. And what that actually gives us is 7 plus or minus the square root of negative 15. Okay, when you go 49 minus 64, you get negative 15 divided by 4. I cannot take the square root of a negative. Okay, so some people wonder, well, does that just get rid of that part, or what does that do? That blows up the whole, it's like dividing by 0. Okay, it blows up the whole universe, and it just gives us, hey, that's a no solution. Okay, no solution there. All right, let's rewrite this one. Okay, I'm not going to pause it and let you try this one. It is a special case, I think, sort of. Not really. But let's just go ahead and try it. We'll get plenty of practice on the backside. So what I want to rewrite this as is I want my c in there because I need that c. So plus 0 equals 0. So here's my a, here's my b, here's my c. So let's see what we have. X equals negative b is negative 50. So negative b plus or minus the square root of b squared. So it's 50 squared minus 4 times 10 times 0, 4ac, all over 2a. Okay. Sorry, that's a little blurry. Let me see if I can't focus that up a little bit. That's better. Okay. This 4 times 10 times 0 just going away because we're multiplying by 0, so that makes it all 0. And so we're left with the square root of 50 squared. Well, what's the square root of 50 squared? Let you think about that. Pause for effect. 50. All over 20. So this is a special case in the fact that, you know, that last term right there went away, and we just got the square root of b squared there. So it's not that special. It's actually one of those cool answers. Okay. So let's see here. We have negative 50 plus or minus 50. So let's go negative 50 minus 50 is negative 100 over 20. And negative 50 plus 50, 0 over 20. So that gives us a negative 5 and 0. Okay. That was just one of those cool answers. I thought I'd throw it in the special cases part. Let's go ahead and turn the page and move on. All right. What I want you to do now is go ahead and pause the video, and you have 4 problems to solve. Okay. On the left-hand side, I want you to use decimal form, and on the right-hand side, use simplest radical form. All right. So go ahead and pause the video and give that a shot. Okay, welcome back. Hopefully those went okay. So on the left-hand side, I'm using decimal form. I'm going to say x equals negative b, so negative 6 is positive 6, plus or minus the square root of negative 6 squared, which is 36, minus, I'm going to write this out, 4 times 9 times 12. Okay, and that's going to be all over 2a, so 2 times 9. All right, so we get 4 times 9 times 12. Ooh, that's a big number. Let me just rewrite until we get there. We'll have 36 minus, that ends up being 432 all over 18. So maybe you felt it up here. I know I did. Maybe you felt it here. I know I definitely did. But what we're going to end up here is we're going to be taking the square root of a negative, which we can't do. But you have to work it all the way down to show that it's going to be the square root of a negative. Okay, it's 396. Negative 396. So we can't do that. So we just say no solution. Okay. And, maybe your calculator would say, like, no real solution, or, it's just like when your teacher way back when told you that you couldn't subtract a bigger number from a smaller number. That you can't do that. That doesn't exist. Well, it turned out that you could. It just gave you negative numbers, and that teacher back there in whatever first or second grade didn't want to deal with negative numbers, so they just told you couldn't do it. Same kind of thing's happening here. If you continue on in math, you'll figure out what the square root of a negative is, but it's not worth the hassle of us doing it right now. Okay? Let's go ahead and look at this one over here. We're going to be using simplest radical form. Hey, lucky sevens. Look at that. So x equals negative b. Negative 7 is positive 7, plus or minus the square root of b squared. Negative 7 squared is 49, minus 4, 7, negative 7. Okay, you should feel sooner or later, hold on, 2 times 7, I'm just going to simplify that, that's 14. Okay, you should feel sooner or later that if you have one negative over here, that's going to make that okay because of that negative 4. All right, so I'm pretty sure I'm going to get a solution here. It won't be a no solution scenario, but let's see what we have. So we have 49, that's going to be a plus. 4 times 7 times 7 is 196 all over 14. And so x equals 7 plus or minus. There's a lot to write here, I know, but you can do it. So we have 245 over 14. Okay, now here we have a little bit of work to do. We have to split up 245. Well, that turns into 5 and 49. 49 is 7 and 7, so 7 has an exit, buddy. So we have x equals 7 plus or minus 7 root 5 over 14. So remember, the way I write it is 7 over 14 plus or minus 7 root 5 over 14. The 7 over 14s can reduce, so 1/2 plus or minus square root of 5 over 2, or 1/2 times the square root of 5, but that's my final answer. Okay? Good job. Let's move on to the last two, and we'll call this a day. And there's a big tear coming out of my eye. We'll call it a year of math. All right? So remember, a, b, and c. So x equals negative b, which is the opposite of negative 11, plus or minus the square root of negative 11 squared, 121, and minus 4 times 10 times negative 17. Close that off. All over 2a. 2 times 10 is 20. Okay, so here we have 11 plus or minus the square root. 4 times 10 times 17, that's a pretty big number. And let me double check that. I know that there's a negative in there, but I'm not too worried about it because it turns it into addition. So we get 801. And sadly, that's not a perfect square, but we are using decimal form. So the square root of that is going to be 26.3. Right? No, 28.3, sorry. All over 20. And I'm going to go ahead and use my calculator again to figure it out. If you don't remember how to do this, this can be a nice little refresher. Plus 28.3 divided by 20 gives me 1.965. We'll say 1.97. And change that to a minus. Negative 0.865, so 0.87. And there we go. Okay, I've found that whenever you're going decimal form, it's usually a little bit of work because you want to actually figure out what the number is, but it does have the advantage of then you actually know what the number is. Okay, let's look at this last one, and here we go. Negative b plus or minus the square root of b squared minus 4ac. Okay, all over 2a, which is 10. So we have negative 10 plus or minus. Hopefully you felt like you were given a little treat here because you have 100 minus 100 under the square root sign. So that's negative 10 plus or minus 0 over 10, which is just going to be negative 1. Okay, so good job. Hopefully you guys learned a little bit this section and this year for that matter. But good luck on the practice application and mastery challenge, and good luck on that last test coming up. See you guys later. All right, when we've been looking at some amazing baseball plays, we saw web gems, throwouts, avoiding the tag, and sort of the coup de grace of baseball is the amazing triple play. And that'll be our last set of videos looking at some pretty cool triple plays. Now that just means that you're starting the inning, you need 3 outs, and you get 3 outs in one single play. I hope you enjoy, and good job this year.
That one bounced. Donaldson has it. Third, second, yes! Triple play! Triple play for the A's, and that ends the inning.
Brett Anderson said, wow, come right back and turn a triple play. How great is that?
8th triple play in Oakland history. Last one was we've showed the Randy Velarde.
On the ground to third base. Lowry touches third, goes to second for 2. On to first, a triple play.
Yes.
How about that? Jed Lowry starts it at third. And around the horn they go for the trifecta. Something happening here since we have not seen since 1994.
Well, it was perfect, Don. Lowry had to take one step to go to the third base bag. He goes to second. They have plenty of time there. And then plenty of time at first base for Dustin Pedroia.
2-2. The runners go. Line drive caught by Brundtland. He makes the tag of Murphy to complete the triple play.
Both runners going. That means that Brundtland's got to move towards the bag at second base. That allows him to not only make the catch, to force out of Castillo, and now, of course, here the tag play on Murphy.
Again the 3-2. And he hits it out there at third, out at second, on to first, got them all, a triple play.
Hit sharply to second. There's one. They throw to third. They got him in a rundown. There's 2. Can they get 3? It's a triple play. How about that for getting out of a jam? A triple play. You got to stick around to see that again.
I want to see you score this right off the top of your head.